Okay, so in this one, we're going to talk more about sums, which is just adding your terms together. And so it's a partial sum is like when you have that many terms, you stop at that number. So I'm going to take the first 3 terms and add them together. So I have an infinite geometric series where they're all getting bigger. I'm multiplying them by 1/2. So my r would be 1/2, but you don't necessarily need that for this problem. If I'm wanting to find the sum, so for part A, I'm just going to add the first 3 terms together. So I'm going to take 1/2 plus 1/4 plus 1/8. And if you type that in your calculator, can anyone tell me what you get? 7/8, good. Or you could say 0.875. I would allow a decimal. So once you found S3, like to find S4, you don't have to go back and do all 4 again. You can take 7/8 plus 1/16. So if you have 1, 2, 3, 4, 5, and so on, to find S4, I'm going to take my previous answer, which is S3, and I'm going to add the next term. So 7/8 plus 1/16 is what? 15/16, which is 0.9375. If I want to find the sum of 5, I'm going to take 15/16 and I'm going to add the 5th term. So 1/32. And you get what? 31/32. Is anyone seeing a pattern? Yes. So if I were to figure out what the 6th term was going to be, what would the 6th term be? 1/64. And then the sum, I'm going to scroll down. So if we were given this formula, as long as the absolute value of your rate is less than 1, if the absolute value of your rate is greater than 1, so if it's a whole number, then it has no sum. So that's important to know. I won't give you that. So if you have a fraction that is less than 1, then this formula will work. So you can say formula works. It all like approaches some sort of number. But then if you have a number that is greater than 1, so the number that is in parentheses, if it's not a fraction, less than 1, then you would say no sum, and that would be your answer. So if I said find the sum of the infinite series, then you would say no sum if it's bigger than 1, and then you would find the sum. That's what it's approaching as it goes to infinity. Then you would use that formula. So if we look at A, I have 5, which is A1, 0.8 is my R, and it's an infinite sum because this infinity sign at the top. So as my I, or my N, is approaching infinity, if I added up all of those numbers, it would approach some number, which this is kind of getting you prepared for when you go to pre-cal and you learn about limits. The limit is approaching infinity. What is the sum going to be? So that's kind of why we're learning this. So my A1, if I were to plug this into the formula, my infinite geometric sum, so like the sum of infinity, is going to be my A1, which is what number? 5/1 minus, and then 0.8, or 0.8, which would be 5/0.2. So you end up getting 25. So the sum is adding up to 25. For part B, I need to figure out what my rate is. So how do you figure out what a rate is in a geometric sequence? You divide. So I'm going to take -3/4 divided by 1, which you end up getting what? -3/4. Is that number less than 1? Yes. Or I guess the absolute value of it is less than 1, the number itself. So that means that this formula will work. So my rate, if my rate is 3/4 or negative 3/4, and I need to figure out what my first term is, which it gives it to me, 1. So A1 is 1. I'm going to plug that into the formula. So the sum as it approaches infinity is equal to A1, which is 1, over 1 minus a negative 3/4. So 1 plus 3/4. So if you plug that in your calculator, you're going to end up getting a fraction. What do you end up getting?
4/7.
4/7. Awesome. And then for part C, I want to find the rate. So I'm going to take my second term divided by the first term. Negative 3/1 gives me negative 3. And since that absolute value is greater than 1, I would say no sum. Okay, for number 2, we have a word problem. It says a pendulum that is released to swing freely travels 18 inches on the first swing. So what do we think that would be? 18 is what? My first term. So A1 equals 18. Good reading skills. On each successive swing, the pendulum travels 80% of the distance of its previous swing. What do we think that 80% means? My rate. So in decimal form, it would be 0.80. What is the total distance of the pendulum swing? So total distance means it wants me to find the infinite sum. That's what total distance says. So the infinite sum, I'm going to use the two variables that I have, and I'm going to plug it in to the formula A1 over 1 minus R. So I plug in what I have. So the infinite sum is 18 over 1 minus 0.8. So 18 over 0.2, which gives me 90. And what is the units are inches. Don't forget units. Okay, number 3 is a little bit different because it gives you the infinite sum, and then it wants us to find, or it gives you a repeating decimal, and then it wants you to find the infinite sum from that as a fraction. So if I were to split this up, I'm going to rewrite this as my first 2, so 0.24 plus 0.0024. So I'm just breaking up the patterns. So it repeats every 2 decimals. You'll see why we do this here in a minute. I'm going to write this in orange. 0.0024. And then the next repeat is plus 0.000024. And so that is the sum where I'm taking first term, like this 0.24 represents my first term, so this is A1. My second would be A2, A3. So when you break up the pattern, that splits it up into first term, second term, third term. The fourth term would be 0.00000024. So you can kind of see the pattern that's going. So the 2 things that I need for my infinite sum is I need the first term, which we now have seen is 0.24. And then I also need the rate. So if I know that my second term is 0.0024, then how can I figure out what the rate is? Good. So I'm going to take the second term and divide it by the first. So 0.0024 divided by 0.24. And what do you end up getting for your rate? 0.01. So now I have my rate and I have my decimal. And so you think to yourself, can I not just plug it in the calculator and put 0.24242424 and then hit math, enter, and write it as a fraction or convert it to a fraction. It doesn't work because it goes on for infinity. So you've got to stop somewhere. So if you put in 0.242424 and then you hit convert to a fraction, it's saying that this next one is 0, which messes up the whole thing. So you can't keep typing for infinity. So that's why we have to do it by hand. And so once you have your A1 and your rate, I'm going to plug it into the formula, which is S of n equals A1 over 1 minus R. So the infinite sum is 0.24 over 1 minus 0.01 or 0.99. And what do you end up getting for your decimal? No. You should get 8 over 33.
That's what it approximates to.
So whenever, like if you type it in and it gives you the decimal and you're like, oh, I just got back to where I started from, if you hit convert to a fraction, then it'll convert it. Because in the calculator, in its mind, it's thinking that it's going on forever. But if you manually type in 0.242424, it doesn't. So that's a fun lesson for the day.